In this video, I will be demonstrating how to use the Excel Analysis ToolPak to estimate a multiple regression model. I've got data for 20 countries that come from the UN Development Program database for the year 2015. What I'll treat as the dependent variables in column B, and that's the average life expectancy in years. The first independent variables in column C, and that's the percent of a population in a country that resides in an urban area. In column D is the second independent variable, and this is health expenditures as a percent of GDP. And lastly, in column E is the average number of years of education. To generate a regression model using the Analysis ToolPak, come up under Data and come over to choose Data Analysis. And what we're going to do is scroll down until we find Regression Routine. Highlight that and click OK. Now, as far as the input for the Y variable, click on that tab, come down and select, and I'm selecting here the label that I have for that variable. Back on this icon to get back to our window. Then for the input range for the X variables, click on this icon. And what I'm going to do is highlight the data in all those cells. And you should have your independent variables in columns that are next to each other, so they're one group. Click OK. Now I did select the labels in the very first row, so I want to click that. And the options we have in terms of output, either output it as a new worksheet or output it in a range on the worksheet which we currently have open where the data are. I'll just start off first of all by selecting the output range, and that I'll put this on this Excel sheet where the data are. I'm just going to select one cell, and what that'll be is the cell that is the upper left-hand cell of the output. Let's go ahead and click OK. And as you'll see, we have our output right here. I'll just make this a little larger so it's easier for us to see it. And we'll go through the output rather quickly here. You notice in terms of the summary output, that first box towards the top, information about the overall model. The multiple R is nothing more than the correlation, the Pearson's R correlation between the dependent variable and the predicted values of the dependent variable based upon the regression model. The R square, and I should say it's also the square root then of the R square. The R square, as we see, a measure of goodness of fit for a model. Adjusted R square takes into consideration the number of independent variables in a model. The standard error that you see there is actually the standard error of the estimate, or standard error of the regression that some refer to it as, and it's nothing more than a measure of the accuracy of the predictions that come from this regression model. It's closely related to the sum of squares. We can kind of think of it as something like a standard deviation of the residuals. That's not quite exactly it, but that's a general idea. Below that is the analysis of variance table, where you see that the sum of squares for the dependent variable is broken down into its two constituent components, the regression and residual sum of squares. Regression sum of squares also sometimes referred to as the model sum of squares or the explained sum of squares, while the residual sum of squares sometimes referred to as the error sum of squares. And then you see the mean sum of squares, the degrees of freedom for each, the F ratio, and then the probability value for that F ratio. Below that, we see the actual estimated regression coefficients, and you notice it places the intercept in the first row, and then the independent variables one at a time in the order that they were entered in terms of columns in your data set that you have there in your flat file. The first column are the coefficients, the regression coefficients. Next to that are the standard errors, and I can make that a little wider there, that column, so you can see that entire label. Next to that then are the t-statistics for each of these coefficients, and it's found by nothing more than taking the coefficient divided by its standard error. The probability value then is nothing more than the significance value for that t statistic that's estimated. And then next to that, you have 4 columns that really present some information in a redundant fashion. You have the lower 95% and upper 95%. What those are nothing more than the confidence interval at the 95% confidence level for each of these coefficients. And you notice it's reported twice, so it seems redundant, but let me go back and show you what happens if we change one option. Go back to Data, Data Analysis, Regression, and let's go down and click on Confidence Level. Let's go ahead and change that confidence level to a value of 99% and click OK. We'll put the output in the exact same place where I had it before, so I'll overwrite it. And now as we scroll down, you notice now we see the latter 2 columns in terms of the table that reports the coefficients are for the lower 99% and the upper 99%. And so what we're able to do there is to change the confidence level that those confidence intervals were computed at, but it always generates then the 95% confidence level. And here I've been able to add the 99% confidence level. So that's why you see those last 2 categories. By default, it will just report the 95% confidence interval again. So now that I've demonstrated how to report the result, or generate the results rather, for a regression model using the Analysis ToolPak in Excel, what I'd like to do now is to demonstrate some of the options that we did not take advantage of a moment ago. Let's go back up to Data, come down to Data Analysis again. Again, select Regression if it's not already there. And recall that what it does, in the same session, it then keeps the most recent input information in terms of this dialog box. I'm going to turn off the confidence level, so we'll just generate then the 95% confidence interval. And what I'm going to do is now report the results to a new worksheet. And I want to add a couple of things to this. I want to add, first of all, the residuals and also the standardized residuals. Click OK. And now you see it added a new worksheet here. Regression output is the same that I showed you a moment ago. As we come down, though, there is now residual output that's put below then the regression model. Now, all of this output is nothing more than character information, so we could easily copy and paste that onto another sheet if we wanted to. But we have, first of all, in the residual output, the observations are listed in order, and then what you see next to that are the predicted values for y based upon the regression model. Next to that, then, are the residuals, which is nothing more than the difference between the actual values for life expectancy and the predicted values based upon the regression model. Just like we would compute any residual, it's y minus y hat, or actual minus predicted based upon the regression model. And there you see residuals. So it's an easy way to generating predicted values of y and also then the residuals. Now that third column is the output when I clicked on standardized residuals. And all these residuals is nothing more than taking the residuals you see reported here in column C in this output and dividing them by the standard deviation. So for instance, to illustrate just what this is, if we go ahead and find the standard deviation, and I'll use the sample formula here for the residuals we have, and keep in mind what the mean's going to be for our residuals. The residuals should have a mean of not quite 0 because of rounding error, but certainly it's 0 up to the 14th decimal place, and then it becomes 5, so this is going to be the average. And this is the standard deviation. And if we do nothing more than take the residuals themselves and then divide them by the standard deviation for those residuals, fix that denominator reference because we're looking at the standard residuals. I'll just use the autofill function here. And you notice what I've just computed is exactly what the standard residuals are. Now, in essence, why they report this is they're trying to give you some sort of output that takes residual values and removes, in essence, the scale of the units that the dependent variable is reported in. And in that case, you'll see, regardless of what the model is, the standard residuals will be sort of the same order that we see for any other model, even if we have a different dependent variable, while the residual values will vary greatly as a function of what units our variables are measured in. But as far as using the standard residuals, these aren't the residuals that are typically used by statisticians for examining the results of a regression model. Typically what you'll see is studentized residuals are generated and are used, but Excel does not report these. What these standard residuals are is just a quick and dirty attempt to try to adjust for, if you will, then the size of the residuals themselves. And if I just take these values, these summary statistics, you'll notice then that we don't change the average because the residuals have an average of 0. But what we've done here is we have taken the residuals that have a value of 5.9 for standard deviation, and now they have a value of 1 for a standard deviation. So this is one quick and dirty little fix to take these residuals and make them more of a standard sort of units, but they're not the kind of studentized residuals that most statisticians would work with. So this is the output you get when you click on residuals and also the standard residuals options in the Analysis ToolPak regression routine. Let's now take a quick look at some of the plots that are output from the regression routine in the Analysis ToolPak in Excel. Let's estimate our model again. Data over to Data Analysis. Make sure regression is selected. We have already the residuals and standard residuals that are generated. Let me go ahead and turn that off just to reduce the amount of output we're looking at. And then I'm going to generate the residual plots and line fit plots and click OK. And here, of course, it adds another sheet since I've estimated the model another time. And what it does, it still, even though we turned off the residual output, it still gives us our predicted values of y and the residuals, and that's likely because some of the output that we just generated in the form of charts utilizes then the residuals. Let's look first of all at the residual plot. So I'll just click on this particular, the first plot that we have here. And you notice it all just is laid one on top of the other, so I'll move some of these out of the way. Let's click and drag all of these. Whoops. And this is similar to what we see in the other residual plots. All it's going to do is take the residuals on the y-axis and then plot them against the values of each independent variable one at a time. Now this is one way in which we can use residual plots to get a sense about whether or not heteroscedasticity is present, and that is non-constant variance in the errors that are generated by a regression model. We can see then this second one is for the second independent variable. Let me generate, here we go, I click on this. And you see now we see the residuals are plotted against the value for health expenditures. And we can do the same thing for the residual plot for the third independent variable. So it's just plotting the residuals against each independent variable one at a time. Now these may not be the most useful residual plots for estimating or detecting whether or not heteroscedasticity is present, but it is a step in the right direction. Now let's look at the predicted value line plots. This is nothing more than taking, first of all, the scatter plot of the y variable by an independent variable, and then also reporting on top of that scatter plot the predicted value of y for each independent variable. And you get a sense then of how far off the predictions are from the actual values of y given your values of x. Let me get the second example. It's right here. Can open this up. Now, I don't find these terribly useful as far as for diagnostic tools. And here's the third one. But it does give you some residual plots as well as some plots of predicted values of y. And now, as you can see, I'm back to the original worksheet where the data are. And just keep in mind that whenever you estimate a regression model or any sort of routine in the Analysis ToolPak, make sure you come back to the sheet where the data are. So I'll come up to Data again, over to Data Analysis. Make sure then that regression is selected. Click OK. The Y range, of course, just again is going to be where life expectancy is, and the dependent variables are going to be in columns C through E, making sure then the labels are selected since I did select the labels there. I'll still keep the new worksheet output. And now the last thing I'd like to do is show you what the normal probability plot looks like. It's a little misleading there. You see normal probability plots, which seems to imply that there's several of them, but you'll see in a second that Excel just generates one by default. And here, again, we see the output, and down towards the bottom, we see the actual values of y, and next to that are the percentiles. And the percentiles then is going to be what's going to be plotted along the x-axis, while the actual values of y are plotted along the y-axis. Let me go back up to the plot that it generated. And right there is our normal probability plot. Now, a normal probability plot is nothing more than a graphic technique for assessing whether or not a variable is approximately normally distributed. And this is a key assumption of regression for hypothesis testing. The data are plotted against a theoretical distribution in such a way then that the points should form an approximately straight line if the data are indeed approximately normally distributed. Now, the particular version of the probability plot that Excel generates here is that of a normal quantile plot, which sometimes you may see referred to as a QQ plot or a quantile plot. And in essence, what you'll notice here then along the bottom is going to be the theoretical quantiles from a normal distribution. And along the side here, we see the actual values of the dependent variable. Now, I mentioned that normality is assumption of regression, of OLS regression for hypothesis testing. More specifically, the assumption is that the residuals, the error terms from a model, should be normally distributed. So it's a little odd then that what Excel does rather is generate then a normal probability plot for the dependent variable. But if you do have non-normality within your model, one of the first places to look at is the distribution of the dependent variable. Maybe that's why they start there. Let me go ahead and adjust these axes just a tiny bit. So I'm going down to Format Axis, and let's go to 45 to 85, and click OK. Right there we are. And I'll do the same thing down here, but instead I'll have the upper limit for this axis to be at a value of 100. Oh, let me do that again. There we go. And typically this is what you'll see, something such as this, where then the data points line up in this sort of a straight angle, if you will, from lower left-hand corner to upper right-hand corner. That's why I adjusted those axes to get more of the data fit along that diagonal. Now, one of the things that you'll notice, oftentimes with the normal probability plot, is that a straight line is depicted along with the data points, so you can gauge exactly what would a normally distributed variable actually look like. And I mentioned it should approximate a straight line. Well, one of the things we can do very easily with this plot, selecting the plot here, come up to design, come over to add chart element, and come down to trend line. We can just simply put a straight line into this probability plot. And what you'll notice then is that your data point should line up very close to this straight line. Now this deviates a little bit towards the lower end, which suggests then that the tails here are off a little bit in terms of the smallest values for the dependent variable, and also deviates a little bit there then towards the lower third. So it pulls away a little bit from a normal distribution, but not tremendously so. And one of the things you might perhaps want to do is to generate these sorts of plots also for the residuals, and that's something in a future video I'll show you actually how to do. But this covers, for the most part, what the output are for the Excel data analysis ToolPak for the regression routine.